Hello, and welcome to the presentation. My name is Josh Polanin. I'm a principal researcher at the American Institutes for Research, and I'm coming to you today from downtown Washington, D.C. Thanks for joining me. And so today we're going to discuss an evidence gap map Shiny application for effect size and summary level data. And so, like I said, this is a collaboration with numerous individuals here at AIR, Chi Zhang, Joe Taylor, Ryan Williams, Megha Joshi, and Lauren Burr. Megha in particular, I'd like to give a big shout out to. Megha was our lead developer on the Shiny application, and she really helped us rethink how to process this information in the R environment. So a big thank you to Megha. I know she's watching, so a huge congratulations to her as well. I'd also be remiss if I didn't thank our sponsors. So the project was originally sponsored by an institute, a U.S. Department of Education, Institute of Education Sciences. So that grant ended a little while ago, and so the Methods of Synthesis and Integration Center, or Mosaic, as we call it, at AIR has picked up some of the slack and helped us get this Shiny application to the finish line. So I'd like to thank both of those sponsors before we go further. So let's then turn to creating one of these gap maps with meta-analytic data, in particular with our Shiny application. Okay, so first things first, where can you find this Shiny application? So AIR has a Shiny application server where we host various Shiny applications. And Mosaic actually has a couple of different Shiny applications that you can take a look at while you're there. But if you're just interested in taking a look at the EGM Shiny app, you go to airShinyApps.shinyapps.io/Mosaic_EGM. It's a mouthful, but relatively simple URL to get to. And you're in the right spot if you find a landing page that looks something similar to this. Now, of course, we're going to keep updating this page, but this landing page will probably look pretty familiar to you once you click on it, regardless of when you come to it. So before we dive into it, I just want to mention a bit about the philosophy and the features of the Shiny app. So the first thing is we wanted it to be compatible with a typical meta-analytic data set. We wanted you to be able to say, okay, I've already done my meta-analysis, probably in R, and I have row level data, effect size level data on the rows. I have several columns that indicate the effect size and the variance and different characteristics of the programs. And we wanted you to be able to take that data set and upload it into the Shiny app and have it work. So that's what it does. We also just wanted it to be easy. So some basic features: uploading effect or summary level data sets. So that means, so again, you can have a row level where each row is an effect size, or each row can be a cell within your EGM. And I'll show you what that means in a minute. You can actually have two, so a traditional two-level EGM is just x-axis and y-axis with multiple categories within those two axes. You can produce that very easily with this Shiny app, or you can actually produce a three-level EGM, which I'll show you what that means in a minute. This is going to give you some really nice summary output. And then, like I said, an easy to copy and paste R code in case you want to do some more fiddling with the GG plots or anything else within the plot itself. Okay, so the live demonstration, finally. So two examples, one using effect size level data. That comes to us from a review that I completed about a year ago on the effects of programs on cyberbullying outcomes. So we're going to look at that. So that's the effect size level data set. And then summary level data set comes to us from that motivational intervention review that I mentioned. And that had 14 different motivational interventions across 3 different outcome domains. And I do want to mention right off the bat, when it comes to loading the Shiny app in Chrome, that there are several dependencies. And so if it takes a minute the first time that you go to the site, don't fear, give it a minute, let it load, and I assure you it'll eventually initialize. So, okay, first things first, go to load data, upload my own data. There is an example already built in here. I'm not going to show you that right now. You're free to play with that if you'd like, but it has all the same features, but we're going to use our own data today. To start off with, we're going to do effect size level data, and then you can actually upload a CSV or an Excel file. We're going to start with a CSV file. Browse. We're going to use this example ES level CSV. Open. Just takes a second. Upload complete. Now, we've got several drop downs here. The first one says, specify the first factor for the EGM. So this first factor is your x-axis. So what do you want on your x-axis to be? It really is your preference. You can go, you can put the outcome down there on the x-axis. You can put the outcome on the y-axis. We're going to go with design on the x-axis. Design is the RCT, QED, individual level, not school level, that sort of thing. So the research design. Then on the y-axis, we're going to go with the outcome, the outcome type. So we've got 2 different outcome types here. We got cyberbullying or aggression or traditional in-person bullying. Now, if we wanted to specify a third factor, we could here. I'm not going to for this round, but I'll come back to it and show you what we do with that. This effect size, so which variable in your data set is the effect size variable. So it's an easy one, it's ES. Then we've made this easy for you. If you happen to have a column that's got standard errors, you can click on that here and we'll transform the standard errors for you. Or if you've got variances for your effect, go ahead and click on variance and then tell it where the column of variances is. And then finally, which column is your study level, study identifier. Now, this is important if you have nested effect size data. And so this would be like if you have correlated effects or hierarchical effects, so multiple effects per study. But even if you don't, you probably have a study identifier. Just go ahead and click on that. And that is it. That's 1, 2, 3, 4, 5 clicks. Then you click on over to create summary data. And the last click you're gonna push is has to do with the assumed correlation among the effects when there are multiple effects per study. 0.8 is generally the correlation that we say is about right. So we're going to use that for now. And then click summary data. And I'm going to expand this to show 25 rows. And now what we see here are our basic summary data. So this is each one of the cells that's estimated. So let's walk through this for a minute. The first column here is the factor 1, the x-axis. So this is our design column. So we've got non-randomized class level assignment, non-randomized individual level assignment, non-randomized school level assignment, randomized class, randomized individual, randomized school, so on and so forth. Then we've got our y-axis. This is our outcome. So we've got 2 outcomes here. We've got aggression or traditional bullying or the cyberbullying. The estimation method here, I'm going to sort by it just so we can see this easily. There are actually 3 different types of estimation methods that EGM will select for you. The most basic one we actually don't have here occurs when you have 1 study and 1 effect. When that happens, there's no meta-analysis that's happening within that cell. It just gives you the basic effect size. If you have 2 or less studies, and 4 or less effect sizes, you're going to get the univariate random effects model. This is just a conservative model that doesn't assume any correlated effects, even though there are effects within study. It does simple averages within the studies to create the average effect per study. And then the correlated effects estimation model is the robust variance estimation method. And that is why we need this little scroll over here. It accounts for the correlated errors within study. Okay, so that's the estimation method. Then the average effect size is exactly what you might imagine it is. It's the average effect for that cell. And so in this particular example, negative effects are a good thing because it means that there's a decrease in bullying or cyberbullying for the intervention group compared to the comparison group. Then we've got the number of studies and the number of effects. So the most studies within a cell is for the randomized individual looking at cyberbullying. We've got 12 studies and 27 effects. And the most effects is 61 actually. And so this is randomized at the school level, and there's 61 effects there. Okay, enough of that. How do we get to an EGM? Click on EGM. There's a couple more drop downs here. This says, the first one says, do you want to map average effect size onto a continuous color? Do you want to overlay anything on the dots? This gives you allows you to say the number of studies or the average effect. I'm going to click average effect so we can see what that looks like. And then the x-axis is the design, and the y-axis is the outcome. That allows you to put any label that you want in there. And when you click create plot, finally we get an EGM. Okay. So if we look here one more time, we can see our typical EGM that we think of. We've got the x-axis is the design. We've got the 6 different cells, 6 different categories for design, 2 different categories for outcome on the Y, and then crossed in there is our average effect for each one of these cells. The average effect corresponds to this color code down here with a -4 being the largest and a dark purple. This, I believe, is set up for people who have color blindness or issues with processing color. So this should be good for those folks. And we've overlaid the average effect within each of the cells. If you want to download the plot, click on this download plot. You can give it a different name. We'll just say for presentation. You can do some stuff with the width of it, but if we download the plot and then we click on it, you can see it. Last but not least is the R syntax. You can copy and paste this right there like that, and this will tell you, this will give you everything you need to reproduce that plot using your own data. Really, that's it. I'd like to thank you all for joining us today. I appreciate any input that you have. I'd like to thank again my collaborators and co-authors, Chi, Joe, Ryan, Mega, and Lauren. If you have any questions, feel free to reach out to me. There's my email. I'm also on Twitter. You can find all my contact information at joshuarpolanin.com. And we look forward to having you all use the program. Have a great rest of the conference. Thanks for having me. Have a great rest of your day wherever you're calling from.